Another common translation or movement of a graph from its most basic position is a movement vertically up or down. Now, I'll be very surprised if when you first started graphing a quadratic, forming a parabola, if you then didn't look at, for example, the graph of y is equal to x squared and you are plussing a 1. And often this is the very next step in sketching after you've learned how to sketch y equals x squared. We now just add 1 to all the y values. Now, what that actually does, and hopefully you'll remember, is it keeps the parabola still here, centered symmetrical around the y-axis, but it pushes it up so its vertex is now up 1 unit high. If you were to then sketch y equals x squared minus 1, you know that that then pushes it down 1 unit, and so you've got this one, y equals x squared minus 1. So adding a constant on here or subtracting it here will push the graph up or push the graph down. Now that is the same with all our other functions. So once I start talking about the cubic, y equals x cubed, add 1 to it, takes the cubic from its original position through the origin up 1 unit. So we're going to sit up here, 1 unit up from its original position. Likewise, subtracting 1 would push it down. Now, it's important to note the difference between adding 1 onto the function and adding 1 directly to the x, which was in the previous video and had a very different result in the positioning of the function. So now we're really adding on to the function. Sometimes you will see this also written as, so taking this constant from here and putting it over on the other side means if it was a plus c here, it becomes a minus c over there. And if it was a minus c here, when we move it over, it becomes a plus. So you may actually see the function written. It's not that common, but you may see it written, for example, this one, as y minus 1 is equal to x cubed. So all I've done is taken the 1 over to the other side. And so you might see a description about impacting on the y component of the function. So to shift a graph C units upwards or downwards, it's going to say replace y by y minus c. Here is our y minus c is equal to x cubed. Or, and remember, if it's y minus c, it really becomes y is x cubed plus c, which pushes the graph up. So a minus c here pushes the graph up. It's a little bit like we saw minusing the x pushed the graph to the right. Adding on c will actually push the graph down, because while we are impacting on the y with y plus c is equal to, for example, x cubed or some function, when it comes to graphing, we like to graph with y the subject, x cubed minus the c, minus the constant, which we know will force our sketch down. So impacting on the y pushes the graph up or down. Now, if you think back to the circle, remember the circle? We can see both of these working, the impacting on the x and impacting on the y. We can see both those work with a circle. So we had y equals x squared is equal to r squared. Then when we wanted to move the circle, for example, to the right, that meant that we had to have x minus something, and we chose to call that h. If we wanted to move the circle up, then we need, oh sorry, did I say y there? I meant x minus h. If we wanted to move the circle up or down, vertically, upwards or down, we impact on the y, and we've seen here that you've got to have a minus c in order to get an impact up. So if we want the centre to move up, then we actually called it k units. What that then resulted in was the centre at this new location, hk, moving it to the right, h units, and up k units. Now, back when I talked about and did the video on the circle, I made reference to the fact that when you do this particular exercise, you'll actually see the formula working according to this generalized pattern about moving graphs on the number plane. So I've put an example like that in here. The formula for the circle, it undergoes a transformation both vertically, up or down, vertically, and horizontally. So this is impacting directly on the y, this is impacting directly on the x. From the origin illustrates both changes. So x minus 1, what's that going to do? That's going to push it across 1 unit, and adding 2 is actually then going to get transferred to as a minus 2, and it will actually push it down 2 units from the centre. So you can see that the new centre becomes across at 1 but down at -2. I'll stop this video here and talk about the next pattern of change that applies to all functions, and that being reflections.